Good afternoon, students. This session is a physics class. Okay. So for the last class, we are seeing about the thermodynamics formulations, right? So on today, we have to continue with the thermodynamical important topics. Okay. First one, Kirchhoff law. Okay. So for explaining this law, we are take it black body. Okay. So Kirchhoff law is applicable to all the bodies. Applicable to all the bodies. So for all the bodies, by taking all the bodies, the ratio of the spectral emissive power, spectral emissive power by spectral absorptive power. So simply we are denoted as E lambda, that is emissive power, and absorptive power, it is A lambda, which should be is equal to constant. So it is very important. So it is constant at a given temperature. Okay. So here E lambda, sometimes we are writing the expressions, that is E lambda is equal to E lambda divided by A lambda is equal to constant. Okay. So here E lambda, which is nothing but the spectral emissive power. Emissive power of ideal black body. Ideal black body at same temperature. Same temperature. So this is the expression. Okay. So E lambda is equal to small e lambda divided by A lambda, which should be is equal to constant. So simply we are saying that it is a ratio of emissive power divided by the absorptive power. Or the value, it should be constant. Okay, it should be constant. It is very important. So in the equation A, we have to write it in many other forms. So எப்படி நம்ம expressions எழுதுறது அப்படின்றத பார்க்கலாம். So here E lambda divided by A lambda is equal to E lambda, that is equal to constant. This is one form, and here it is E lambda, which is proportional to A lambda. Okay. Or we are write it the expression for two bodies now, it is E lambda divided by A lambda for the first body, and E lambda divided by A lambda is equal to second body, which should be is equal to constant. Okay. So in the expressions, we are write it either this form, this form or this form. All of the equations which is under Kirchhoff's law. Okay. So this is very, very important. That is the emissive power by the absorptive power of the values. It should be constant everywhere. Okay. So here we have to notice that is the black body. So what is the speciality of black body? Yes, whatever the radiations, it should be absorbed. That much amount of the radiation, it should be emitted. Okay, absorption, emission, it should be the same for a black body. So adanala emission order emissivity order value for a black body, which is nothing but 1. E is equal to 1. The emissivity order values நம்ம நிறைய formulasல யூஸ் பண்றோம். Even Stevens lawsல கூட நம்ம we have to use this one. So அந்த இடத்துல நம்ம black body apply பண்ணும்போது what is the value of E அப்படின்றத we should know. Okay. Next one, the law are related with one question. So you have to try to answer this one now. Okay. So from Kirchhoff's law, the ratio of emissive power and absorbed power. That is the absorption power. Absorptive power, absorption power, all are the same terminologies of all bodies. All bodies, they are given the options that is or different. And for option B, yes, equal to emissive power of black body at same temperature. Then option C, it is equal to emissive power of white body. And option D, it is equal to emissive power of black body at any temperature. So these are all the options. So which one is apt for this Kirchhoff's law? Put it in the comment box. Yes, it is absolutely B is the right answer. B is the right one. Okay. Okay, very good. Next, Wien's displacement law. So Wien's displacement law. First, I write it the expression for Wien's displacement law. That is lambda m is inversely proportional to T. Okay. So what does mean by that lambda m? Lambda m is nothing but it is lambda, which is nothing but wavelength. M, it stands for maximum. Okay. So the wavelength corresponding to maximum emission of radiation. Okay. So lambda m, which is nothing but the wavelength corresponding to maximum emission of radiation. Emission of radiation. Absorption அப்படின்னா உள்ள அப்சர்வ் பண்ணி இருக்கிறது. ஓகே. எமிஷன் அப்படின்னா வெளியில வர்றது. ஓகே. ரேடியேஷன் வெளியில வர்றது. So sun emits enormous amount of energy. So this is the example. Okay, for emission. Okay. Right. So here lambda m, which is nothing but the maximum wavelength. Okay, maximum wavelength of radiation emission. Okay, so here we noticed that lambda m and T. Okay, lambda m and T is inversely proportional. Either lambda m it is increases அப்படின்னா T oda value it is decreases. T oda value increases. So here it is increases and the down arrow it is represented as a decreases. Okay. So lambda m decreases na. What about T? What about T? When the lambda m value it is decreases means T oda value it should be increases or decreases. Answer comment பண்ணுங்க பார்க்கலாம். Yes, it is increases. One value it is decreases அப்படின்னா automatically T oda value it should be increases. Here it is decrease and here it is increase. Okay, lambda m opposite relation அப்படின்றத we are keep in mind. Okay, so Wien's displacement law அப்படினாவே நம்மளுக்கு என்ன ஞாபகம் வரணும்? lambda m it is inversely proportional. Okay, inversely proportional அப்படின்றத we are keep in mind. Okay, so இப்போ இந்த displacement லாவையும் நம்ம வேற ஃபார்ம்ல ரெப்ரசன்ட் பண்ணலாம். so எப்படி ரெப்ரசன்ட் பண்ணலாம்னு பார்க்கலாம். so here lambda m which is proportional to 1 by t. so now I am removing the proportionality constant, proportional. So we are adding one constant. By removing the proportionality, we are adding the constant. So here it is a small b. Okay, so it is b by t. Here it is lambda m. Or in the equation என்னமா change ஆகும்? b which is nothing but it is a constant. b which is nothing but it is a constant. So in this equation, b which is nothing but Vn's constant. Vn's constant. Vn constant oda value it is 2.93 into 10 power of minus 3 meter Kelvin. That is the answer. Okay, right? Lambda. So now we are just cross multiplying in this equation. We are getting lambda m into t. Okay, lambda m into t is equal to b. So this is or this equation is also Vn's displacement law equation. So for Vn's displacement law nama எத்தனை formula எழுதலாம்? It is one form, it is second form and it is third form. So எல்லா equationsமே எதுல underல தான் வரும்? It is Vn's displacement law. Vn's displacement law ஓட equations மொத்தம் எத்தனை இருக்கு? டோட்டலா 3 equations இருக்கு. Okay, so in the equations it is very important for problem oriented. Okay, பார்க்கிறதுக்கு it should be a simple formula, but இந்த formulas தெரிஞ்சாதான் இந்த constant values தெரிஞ்சாதான் நம்மளால problems work out பண்ண முடியும். Okay, right. Up to this clear? Yes. Okay, now we are writing the dimensions for b, that is the Vn's constant oda dimension. Sometimes it may ask, so dimensions தெரிஞ்சுக்கலாம். Okay, dimension b oda dimensions என்னன்னு சொல்லுங்க பார்க்கலாம். Here it is lambda and here it is t. What is the dimensions of the b? So for wavelength lambda, okay, and t which is nothing but it is the temperature, and lambda which is nothing but a wavelength. Okay, lambda m which is nothing but it is a wavelength. Okay, and t which is nothing but it is a temperature. Okay, so wavelength Abdinave, it is L. And here temperature, either we can mention theta or K. Right. L, K or L theta. Okay. So now I write the dimensional formula, that is M0 L power 1 and T power of 0. And here I can take it a theta value, that is 1. Either we are taking theta or K. Okay. LK. It is also correct. It is M0 L1 T0 K. It is also right. Or simply we are write it as LK. It is also right. Okay. So options la பாருங்க, இதுல என்ன மாதிரி ஆப்ஷன்ஸ் MLT கொடுத்திருந்தா ஃபுல்லா எல்லாமே பாருங்க. இல்ல LK, LK inverse அந்த மாதிரி LK of power of 0 அப்படின்னு கொடுத்திருந்தாங்கன்னா we are directly taking this LK value. Or MLT ஓட ஆர்டரா கொடுத்திருந்தாங்கன்னா we are writing, we are chosen either this one or this one. Okay. Next we can go for the problem which is related with this law. Vien's law ஓட கனெக்ட் ஆயிருக்கக்கூடிய ப்ராப்ளம்ஸ் எல்லாம் இப்ப நம்ம பார்க்கலாம். Okay. So first simple one. Laws we can choose. Okay. According to Vien's law, Wien displacement law, all are same. Okay. Option A, it is lambda m into T is equal to constant. And option B, it is lambda m by T is equal to constant. And C, T by lambda m is equal to constant. And D, T plus lambda m is equal to constant. So which one is right one? So we are known that formula for the third one, that is lambda mt is equal to B. Here B, which is nothing but it is a constant, no? So which option is right? Yes, absolutely. First option is right. Okay, very good. Next. Second one. The surface temperature of the sun. Yes. Option A, it is 2900 Kelvin. And option B, it is 4000 Kelvin. And for option C, it is 5800 Kelvin. And option D, it is 9000 Kelvin. So which one is right? Yes, it is on answer C. So this is the very simple question, but you know the answer by this time. In the time the answer தெரிஞ்சிருக்கணும். Okay, 5800 Kelvin is the surface temperature of the sun. Okay, very good. Next, third one. So write down the problem in your notebook. If wavelengths of maximum intensity of radiation emitted emitted by the sun and moon are 0.5 into 10 power of minus 6 meter and 10 power of minus 4 meter respectively. Okay, then the ratio of their temperature is what? They are given the options, that is A, it is 1/100, and B, it is 1/200, and option C, it is 100, and option D, it is 200. Okay, so here we noticed that lambda 1 and lambda 2 values are given. So this is for lambda 1 and this is for lambda 2. Now we are asking the ratio of their temperature. Okay, so let us now go for the solution. So here we can use the Vn displacement law formula, that is lambda m of t is equal to constant. Okay, so here they are asking, they are comparing two things, no, that is sun and moon. Okay, so sun and moon அப்படிங்கும்போது this formula we have to write it for sun and moon. For the first one it is T1 lambda 1 and the second one it is T2 lambda 2. Okay, so I directly write it the formula, that is Tu lambda, it is inversely proportional. So here you are writing T1 na adoda opposite la enna varum, inversely proportional la it is lambda 1, and here it is T2 abdina we have to write it the opposite lambda 2, that is lambda 2. Okay, so let us now write it down the value for lambda 1. What it is? 0.5 into 10 power of minus 6 and lambda 2, which is nothing but 10 power of minus 4. Okay, so let us now substitute the values for lambda 2 and lambda 1. What it is? 10 power of minus 4 divided by 0.5 into 10 power of minus 6. So solve பண்ணிட்டு என்ன ஆன்சர்னு சொல்லுங்க பார்க்கலாம். Yes, Snega, it is very good. It is என்ன ஆப்ஷன் வருதுன்றத you have to work out பண்ணி சொல்லுங்க பார்க்கலாம். Formulas substitute பண்ணிட்டு So let us now substitute in the formula, that is 10 power of minus 4 into 10 power of 6 divide by 5 by 10. 0.5 you are writing 5 by 10 now. Okay, then 10 power of 6 minus 4, it is 2. 10 power of 2. So it is 10 power of 2 into here you can have to converted or reversed. Okay, so 5 by 10 it is going to above being more than it is 10 by 5. 10 by 5. Okay, so here it is 10 power 2. So 10 power 2 means it is 100. Okay, 10 square it is 100, and here 1 time and here it is 2 time. Okay, so 2. So the answer is it is 200. So the option D is the right one. Okay, option D is the right one. Very good. Next one. Fourth one. The maximum energy. The maximum energy in thermal radiation. In thermal radiation from a source occurs at the wavelength 4000 Armstrong unit. 4000 Armstrong unit. Then what is the effective temperature of the source? Effective temperature of the source is N. Okay, so here it is 7000 Kelvin, and for option B it is 80,000 Kelvin, and for C it is 10 power 4 Kelvin, and for option D it is 10 power 6 Kelvin. Okay, A, B, C, D. Okay, so let us now solve this one. I will give you one clue. So that is, we are using a lambda m is equal to B by T formula. Okay, formula we are take it as a Vn displacement formula. Okay, so they are asking the effective temperature. So but temperature mattumna we need. So but temperature அப்படிங்கும்போது by changing the expression, that is T is equal to B by lambda M. So the values substitute பண்ணுங்க பார்க்கலாம். 2.93 into 10 power of minus 3 divided by 4000 into 10 power of minus 10. So substitute பண்ணிட்டு எனக்கு என்ன ஆன்சர் வருதுன்னு சொல்லுங்க பார்க்கலாம். Yes, it is option A. So option A எப்படி வருது அப்படின்றத we have to check it. Okay, check பண்ணலாமா? Here it is 2.93 into 10 power of minus 3 divided by 4000 into 10 power minus 10. Okay. For Armstrong unit, that is 10 power of minus 10 meter. Okay, right? Here 2.93 into 10 power of minus 3 and 4000 la in the 1000 ku we are putting 10 power of 3. Okay, into 10 power of minus 10. Okay, for the next step, we are taking all the powers in the above. Okay, so 2.93 divided by 4 into 10 power of minus 3 into this value. Okay, this value is going to up and this value is going to up. So this is 10 power of minus 3 into 10 power of plus 10. Okay, 10 power of minus 3 into 10 power of 10. Okay, so here it is 10 power of minus 6 into 10 power of 4. That is 2.93 divided by 4. Okay, next one. 2.93 divided by 4 into 10 power, that is, sorry, here it is 10 power 10. Okay, so it is 10 power 4. Okay, so what is the remaining? 2.93 divided by 4 into in the values in the 2 digits number whole number பண்ணனும் அப்படிங்கும்போது we are just multiplying the number by 100. So அதனால இந்த 10 power 4 நம்ம என்னவா எழுதுறோம் அப்படின்னா it is 100 into 100. So this is 10 power 2 and this is one more 10 power 2 which should be is equal to 10 power 4. So in the மேல இருக்கிற 10 power of 4 we have to split it into 2 into 2. So but 10 square oda value it is 100 and one more 10 square oda value it is 100. Okay, so இப்ப இந்த 100 ஆல மல்டிப்ளை பண்ணும்போது இந்த வேல்யூஸ் எல்லாமே நமக்கு என்ன ஆயிடும், ஹோல் வேல்யூஸா கன்வெர்ட் ஆயிரும். சோ இப்ப நம்ம என்ன எழுதலாம், 293 by 4 into 100. Okay, into 100 அப்படிங்கும்போது we are adding the 0 here. Okay, so let us now cancel this one. So either two formula, that is 14650, and one more time, that is 7325 Kelvin. So this is approximately 7325. We are take it as a 7000 Kelvin. So this is option A. Option A is the right one. Okay, idhe same problem liye they are given the wavelength value different. Okay, so in this problem the wavelength value they are given as 4000, no? Here 4000, no? They may be asked in 5000, 5500, 6000, 7000 and all. Okay, so எப்படி கொடுத்தாலுமே இந்த ஃபார்முலால சப்ஸ்டிட்யூட் பண்ணிட்டு நம்மளுக்கு வொர்க் அவுட் பண்ண தெரிஞ்சிருக்கணும். Okay, in this problem it is clear, children? Put it in the comment box. Yes, very good. Next we can go for the next problem. So next is one. A black body has minimum wavelength, sorry, maximum wavelength. Maximum wavelength lambda m at a temperature 2000 Kelvin. Its corresponding wavelength at temperature 3000 Kelvin will be what? So this is the question. Maximum wavelength lambda m இருக்கும்போது it is 2000, that is for first one, and 3000 convert ஆகும்போது wavelength oda values la enna changes irukum. Okay, that is the question. So here they are given the options, that is 3/2 lambda m, and option B it is 2/3 lambda m, and C it is 4/9 lambda m, and for D it is 9/4 lambda m. Okay, this is the options they are given. So let us now solve this one solution. So here we know the value for lambda 1 and temperature. Okay, so let us now write the formula, that is lambda 2 we are writing is equal to lambda 2 divided by lambda m1, which should be is equal to T1 divided by T2. Okay, so let us now change the formula, that is lambda m2 is equal to T1 divided by T2 into lambda M1. So we have to substitute the value for T1 and T2. T1 value, T2 value, we have to substitute. Okay. So here lambda M2 value should be is equal to 2000 by 3000. Okay. So here lambda M1. So in that problem, for they are given only the first wavelength is represented by the symbol, it is lambda M. So which should be equivalent to lambda 1. No, lambda 1 oda value தான் நம்ம என்ன எடுத்திருக்கிறோம், lambda m ன்னு எடுத்திருக்கிறோம். So இதுல நம்ம final result 2/3 into lambda m அப்படின்ட்டு எழுதலாம். Okay. So which option is right? Yes, it is option B is the right one. Yes, very good. Yes. Next, we can go for the one more law. That is Stephen's law. Okay. So here, Stephen's law would a statement we are going to the equation, that is emissive power of a black body is directly proportional to fourth power of its absolute temperature. Okay. So we are writing the expression, that is emissive power of a black body. So simply first we are writing the expression for E. Okay. So E, which is directly proportional to T power 4. Okay. So this is our Stephen's law. Okay. Stephen's law equation நம்ம எப்படி கொண்டு வரோம் அப்படின்னா main equationல இருந்து. Okay. So what is the expression for the Stephen's law அப்படின்னா E is equal to proportionality remove பண்றதுக்கு we are adding one constant, that is E is equal to sigma into T power 4. Okay. So we have to remove the proportionality. So we are adding one constant, that is sigma. Okay, right. So what is meant by the value for sigma? Sigma, which is nothing but it is a Stephen's constant. Stephen's constant, and it is the value 5.67 into 10 power of minus 8 watt by meter square and Kelvin power 4. Okay, so that is the value for sigma, and here E represents the emissive power. And T represented as absolute absolute temperature. Okay. So from the law we are writing the expressions, that is E, which is directly proportional to T power 4, and which should be is equal to E is equal to sigma into T power 4. இது மட்டும்தான் ஸ்டீஃபன்ஸ் லாவா? இல்ல. சோ இந்த ஸ்டீஃபன்ஸ் லாவா நம்ம எதுல இருந்து டிரைவ் பண்றோம் அப்படின்னா, இதோட மெயின் ஈக்குவேஷன் ஒன்னு இருக்கு. That is E, which should be is equal to E into sigma of T power 4. Okay. So this is the basic equation. So here E, which is nothing but small e, which is nothing but emissivity. Emissivity. Okay. So the Stephen's law, you are clearly notice that Stephen's law is applicable to a black body, right? So in that black body la nama enna sonnom, E oda value should be equivalent to 1. Okay, so perfect black body la adoda value enna, it is equivalent to 1. So adanala E is equal to sigma into T power 4 அப்படின்றத நம்ம ஸ்டீஃபன்ஸ் லாவா கொடுக்கிறோம். ஓகே. சோ இந்த ப்ராப்ளம்ஸ் ஒர்க் அவுட் பண்றதுல எமிசிவிட்டியோட வேல்யூஸையும் சம்டைம்ஸ் தே ஆர் கிவன். ஓகே. பிளாக் பாடின்னு கேட்டாங்கன்னா எமிசிவிட்டியோட வேல்யூ இட் இஸ் ஈக்குவலன்ட் டு 1. ஓகே. So this is one form of Stephen's law. இது மட்டும் இல்ல, இன்னும் வேற another formatடும் இருக்கு. அந்த formats என்னன்னு பார்க்கலாம். ஓகே. Right. One more formula, that is this is also Stephen's law, that is E is equal to E into sigma of, suppose we are comparing two temperatures, either a body temperature or the surrounding temperatures அப்படின்னா, we have to take it the time quantities, that is the T power 4 minus T naught power 4. So this is also one more equation for Stephen's law. And here E, which is nothing but emissivity, and T, which is nothing but temperature of the body, and T naught, which is nothing but surrounding temperature. Okay, this is one more form. And next one, yes, black body means it is the absorption and emission, it should be the same. Whatever the radiations, it should be absorbed, that much amount of energy it should be released. That is the speciality of the black body. Then one more, here E represents the emissive power, no? Emissive power, right? And power, we noticed that power, which is nothing but work by time, no? So we are writing Q by AT. Emissive power, we are writing Q by AT. What is meant by that Q? Q, which is nothing but energy, and A, it is area, and T, it is time. Okay. So simple, emissive power நம்ம எப்படி define பண்றோம் அப்படின்னா, it is a radiant energy. Radiant energy emitted, energy emitted by a perfect black body. Perfect black body per unit area per second. Okay. So the E represented as a emissive power or radiation emission. ரெண்டுமே சொல்லலாம். Okay. So the radiation emitted, the energy emitted by the perfect black body per unit area per unit time. Okay. So equation E எப்படி நம்ம represent பண்ணலாம்? E is equal to Q by AT. Okay. So which should be is equal to நம்மளோட common equation என்ன எழுதணும் லாஸ்டா? That is E is equal to emissivity ஓட இருக்கிற equations எழுதிக்கணும். So E is equal to E into sigma of T power 4 அப்படின்றத we know. So அதை இங்க நம்ம expressionல எழுதிக்கிறோம். So E sigma T power of 4. Okay. So இந்த equationsல இருந்து we are just cross multiplying. That is the Q value should be is equal to cross multiply பண்ணோம் அப்படின்னா Q value நம்மளுக்கு கிடைக்கும். That is the energy value. That is Q is equal to A into T into E into sigma into T power of 4. Okay. So this is the very, very important relations. So problems and all we are using in that relation for Q. Q calculation la in the format நம்ம use பண்றோம். Okay. So here A, which is nothing but area, and T, which is nothing but time, and E, which is nothing but emissive power, emissivity constant ன்னு கூட சொல்லலாம். It is emissivity, and sigma it is Stephen's constant, and T, it is absolute temperature. Okay. Right on? Right. So once again, we can write it all the important Stephen's laws alone. Okay. So we are keep in mind that. So T, which should be is equal to sigma T power 4. So this is one form. And another form E is equal to E into sigma of T power 4. Either E is equal to E into sigma of T power 4 minus T naught power 4. Then one more formula for energy. Here E and Q both are the same terminology. Okay. E, which is nothing but it is the emissive power, and Q, which is nothing but it is the energy. Okay. So what is the difference between E and Q? அப்படின்றது உங்களுக்கு தெரியணும். Okay, then we have to find out the Q value, that is A T E sigma T power 4. So the 4 relations, it is under which law? It is Stephen's laws. Okay. Next one. So then we are writing the cooling rate formula. So you are just taking equation 4, that is taking the d by dt value, that is dq divided by dt. Okay, differentiate pannom appadina we are getting cooling rate or cooling by radiation oda expression. Okay, so either different dq by dt in the equation, fourth equation number fourth equation differentiate pannom அப்படிங்கும்போது இந்த t oda value it becomes 1. So a into e into sigma of t power 4, that is a change in temperature rate of rate அப்படின்னு calculate பண்ணாமவே there should be some changes. So we are writing the temperature, that is t power 4 minus t naught power 4. Okay, so this is the expression for cooling rate. Cooling rate or either cooling by radiation. Cooling by radiation oda expression கேக்கும்போது இந்த ஆப்ஷன்ஸ் நம்மளுக்கு சூஸ் பண்ண தெரியணும். Okay, up to this clear? Let us now go for the problems. Problems and related expressions. Okay, try to answer this one. So if the radius of the star r and it, radius of the star is r and it acts as a black body what would be the temperature of the star in which the rate of energy protection in Q. Okay, now they are given the options. Q by 4 pi r square into sigma. Then option B, it is Q by 4 pi r square sigma the whole power minus half. And option C, 4 pi r square Q divided by sigma the whole power half, 1 by 4. And for option D, it is Q by 4 pi r square sigma the whole power 1 by 4. Okay, so this 4 options they are given. Let us now check which options is correct. Okay. So far, we are taking the expression Q is equal to A into T into E into sigma into T power 4. Okay, right? So if you notice the options, there is no T. So T oda options illa, timing அங்க தேவை இல்ல. So அதனால இந்த T நம்ம consider பண்ண தேவை இல்ல. Okay, simply we are taking Q is equal to sigma into E into A into T power of 4. Okay, so let us now convert it into T forms. They are asking T. Okay, so we just rearrange this one. Q divide by the T power 4 மட்டும் வர மாதிரி நம்ம equation set பண்ணோம். So இப்ப Q divide by sigma EA, which should be is equal to T power of 4. Okay, so then we have to write the expression, that is Q divided by sigma EA the whole power 1 by 4, which should be is equal to T. Okay, so here E, which is nothing but it is the emissivity. So black body அப்படின்னு கேட்கும்போது sun star emissivity oda value it is equivalent to 1. Perfect black body க்கு நம்மளுக்கு values it is equivalent to 1 அப்படின்றது தெரியும். So அதுல இருந்து next step Q divide by sigma into A the whole power 1 by 4, which should be is equal to T. Okay, right. Next one more. Here they are given the star, no? So for the sun and stars, we are having the shape that is the circular shape, right? So for the circular areas, we are having the value that is 4 pi r square. 4 pi r square. So let us now substitute A value into this expression. Okay. So let us now write Q divide by sigma into 4 pi r square the whole power 1 by 4, which should be is equal to T. Okay, all right. So இதுல இருந்து நம்ம options வந்துச்சான்னு பாருங்க, check பண்ணுங்க. It is option 4. Okay, so Q by Q by 4 pi r square sigma the whole power 4, which should be equivalent to T. Okay, so this is option D. Option D is the right one. Yes, very good. Then one more problem. It is problem number 2. The rate of radiations. The rate of radiation of a black body at 0 degree Celsius is EJ by S. Okay. Then the rate of radiation of this black body at 273 degrees centigrade. 273 degrees centigrade will be what? So that is the question. So here the options are 16E and B it is 8E and C it is 4E and D it is E. Okay. So let us now write it the simple formula, that is by taking Stephen's law. Our simple formula E is equal to sigma into T power 4, no? So here when we are comparing this two value comparison abdinave, we just neglect the constant value. That is sigma value, we need not worry about that. Okay. So in the sigma oda values நம்ம cut பண்ணிக்கலாம். Next go for the solution. The formulation, it is E1 divided by E2. E1 divided by E2 is equal to T1 divided by T2 the whole power 4. Let us now we are they are given the values in centigrade. Okay, now we are converted into Kelvin, means you just add the values, given values by 273. Okay, so let us now write the value for here. For the first value we have to mention it as E, and for the second values we have to substitute, that is E2. Okay, so for the temperature we are adding 273 for 0 degree and 273 for 273 degrees Celsius. Okay, it is whole power 4. Okay, here it is 273 and here if it is add na, it is 5 4 6. It is power 4. E by E2. E by E2. Then here this is 1 time and this is 2 time. So E by E2 is equal to 1 by 2 the whole power 4, which should be is equal to 1 by 16, that is E by E2. So here what is the value of E2, which should be is equal to 16E. Okay, so this is the solution. This is option A. Yes, very good. This is option A is the right one. Up to this all the problems are clear, children? It is easy to solve. So எல்லாராலையும் இந்த problems எல்லாமே attend பண்ண முடியுமா? It is clear or not? Yes, thank you. It's very clear. Okay, children, thank you for your cooperations. And some more problems is there, so it will be continued in the next class. Okay. Thank you.